Hi everyone, this is our next lesson on angles and arcs as we continue talking about circles. This is section 10.2.2 and first, as usual, I'd like to talk about some prior knowledge that might be worth talking about. On the previous lessons, we went over arc length and sector area, which introduced a couple of key elements. One is the location of the central angle. Central angle that we see here in the picture, it's called central angle because the vertex touches the center, which is going to come up a little bit later. Also the arc. So we talked about arc being like this crust of the pizza. So we have looked at finding measurement of the arc. We have looked at finding the area of a sector. We have used central angle before. So some of that's going to come back in this lesson. But mainly we want to understand this connection with an arc and an angle that we're going to see in a little bit. All right. So moving forward, I'm jumping to, I think I'm skipping a problem. I'm jumping into problem 62, which has us looking at circle T, circle with center T. We have angle STU is identified as a central angle, which has a measurement of 45 degrees. So here we have STU. This angle corresponds to, belongs to, is connected to arc SU. So you'll notice SU has this little arc on top of it. This means arc SU, which means if I'm looking at the picture, I'm talking about this arc. So the central angle and the arc correspond to each other. So what we're looking to do is understand what an arc measure is. So we want to actually find what is the measurement of this arc. So here's a definition. The measurement of its corresponding central angle. Right? And I've added here in degrees. So if I want to know the measurement of an arc, then I could look at the central angle that it corresponds to. All right, so if I'm looking to find the measurement, this little m in front means measurement, the measurement of arc SU, the measurement of arc SU, which we talked about before, I want to know what the measurement is in degrees. Well, I'm going to look at the corresponding central angle. So the corresponding central angle is 40 degrees, which means this is going to be equal to 40 degrees as well. So let me write that in. So this is going to be 40 degrees. And that's it. So if you have the central angle, there's really not much work to be done besides just knowing this is going to be the same measurement. To make the problem a little bit more challenging, I might ask you, what's the measurement of an arc SZU? So that means we're going from S to Z to U. I want to know what the measurement of that is. Well, if SU is 40 degrees and the full circle is 360 degrees, right? 360 degrees, then what's remaining? So 360, so this portion here is going to be 360 minus the 40 degrees, which comes out to 320 degrees. All right, so let me write that out. So this is going to be 360 degrees minus 40 degrees, which is 320 degrees. All right, simple subtraction to get us our answer. So usually there's an issue with arc measure because there's confusion with arc measure and arc length. So don't confuse those. Those two things are not the same. They both talk about the arc, One talks about the measure, which is in degrees. The other one talks about the length, which we've already done this with the length. So here's a reminder of a problem we've seen before in some way. I'll step you through it, but I pretty much have it worked out for us. So if the circle has a radius of 12 inches, notice the radius is given to us here. What's the arc length of SU? So in the previous portion we asked what's the arc measure, and we said it was 40 degrees. But now we're asking for the arc length. And so I reminded us of the formula we might be able to use to help us find the arc length. So the arc is a portion of the entire circumference. So if I want to find the circumference or the distance around the circle, I would use 2 pi r. But since I only want a portion of it, so if I'm looking at a sector, in this case, this would be like the crust of the pizza I want to find. This is only 40 degrees. So therefore, I don't want all 360 degrees. I want only 40 out of the 360. All right, so this tells me basically what portion of the circle that I have. So I'm going to plug in the central angle, and I'm also going to plug in the radius, which is 12 inches. And then once we simplify it, this turns into 24 pi over 9, which reduces to 8 pi over 3. Notice the units are in inches, not degrees. So when we compare our two answers, 40 degrees and 8 pi over 3 inches, these are not the same answer because they're using different units. All right, so be careful there. So arc measures in degrees, arc length is going to be something you might measure with a ruler. Inches, centimeters, maybe even feet. All right, so that's just a note. Don't confuse the two. You definitely need to know how to solve both types of problems. All right, next key topic on this lesson is what an inscribed angle is. So this is part, just kind of have some notes for you to kind of maybe copy down, have in your notebook. I'll go through and explain this. So a couple things is what an inscribed angle is in our situation. We identify an inscribed angle as having its vertex on the circle. So if we look on the circle and we see an angle whose vertex is kind of that middle point of the two segments. If it's on the circle, then we call that an inscribed angle. So there's two angles we're talking about here in this picture. So when we talk about angle BAC, that point A is at the center, so we call it a central angle. But if I take that and I kind of push it to the edge, and now it becomes BDC, this new angle. Since D is on the circle, we call this an inscribed angle. All right, so you'll notice the difference there. So two types of angles you need to know: central angle, inscribed angle. So they both share the same intercepted arc. So intercepted arc refers to this arc here, BC. You'll notice it goes from B to D to C, just like it goes from B to A to C. So they both begin and end at B and C. So intercepted arc. So because they both have the same intercepted arc, there's a special relationship between these two angles, which is the next part. So the measurement, if I want to actually know the measurement of an inscribed angle, and this is BDC again. We're talking about angle BAC. if I say this is 120 degrees, I want to know what this angle measurement is. So according to this definition, the measurement of an inscribed angle is half of the central angle, assuming they're sharing the same intercepted arc. So these two share the same arc, which is good. Inscribed angle is BDC, and the central angle is BAC. All right. So if I say BAC is 120 degrees, then what is BDC? All right, so if central angle, it says central angle is 120, so therefore if the inscribed angle is half, right, half of the inscribed, oh, I'm sorry, half of the central angle, then our inscribed angle must be, this is going to be 60 degrees, right? So if you know how to divide by 2, then this should be pretty easy for you. So inscribed angle and central angle, they are related. As long as they share the same intercepted arc, it's going to be very easy to calculate one if you have the other. All right, so, and that's pretty much the key of what you need to get out of this lesson. Really, most of this is just practicing. So I'll give you a minute. This is probably a good time to pause before I go through these problems, and I'll try to go through them quickly. But if you want to see if you could figure out the values of x and y in all these situations, x, y, z, try to find the value of x, y, and z in all these. Using what we just talked about, and anything else you might know about triangles or angles you could use as well, or circles. All right, so take a minute. I'd probably pause it if you're going to try to work these out on your own to see if you could get them correct. If not, I'll work through these right now. Kind of my thought process. I'll try to go through these quickly. So let's see. Let's start with the first one. So when I look at the first one, this is part A. I notice a couple of things. I have an inscribed angle given because it's on the circle, which means I need to figure out the measurement of the inscribed angle, and it seems like the only thing I know is this arc. So if I think about what we learned earlier, there was a connection between the central angle. You'll notice there's no central angle here, but if I draw it in, there's a connection between the arc and the central angle, and that is they are the same. So this must be 118 degrees. And then the next part is I know there's a connection between the central and the inscribed. So the inscribed was always half of the central angle or the arc. So in this case, x is going to be 118 divided by 2. All right, so whatever that is. So this is going to be, what, 59 degrees. All right, second problem, part B, kind of the same situation. We have an inscribed angle and we have an arc. So I notice on the first one, I drew in the central angle. The reality is, did I need to draw that in? All I needed really is the arc. All right, so I didn't really need to draw the central angle since these two numbers were always the same. So when I talk about the central angle and the arc, they're kind of the same thing. So in this case, this arc is the same as the central angle. And I know there was a special connection between the central angle and the inscribed angle. So if the inscribed angle is half, then the central must be twice as big. And you should notice it looks a little bit wider if I draw in the central angle. So in this case, x is going to be twice as big as 41, which is, in this case, 82 degrees. All right, and then part C, you might notice there's a center point, and there's a line that goes through it, which we call the diameter. So we've actually cut this circle in half, and inside of that semicircle, there's a right triangle. And so we're going to use possibly use some of that to help us. So the first thing is, if it's half of a circle, that must mean that this is 180 degrees. So I'm going to say x is equal to 180 degrees on this one, which means y and z must equal to 180 degrees together. So I'm going to focus on y. So on y, arc y, I notice it's connected to this inscribed angle, which has a measurement of 78 degrees. So if I want to figure out the arc, then I would double it. So 78 times 2, so 70 times 70 is 140, plus another 16, so this would be 156 degrees. All right, and then one last arc to find. You have a couple options. You could either figure out what the other angle is here, based off of this 78, so that would be like a 12 degrees, and then you could figure out z, or you know that a full circle is 360, and you know two of those, and maybe you could figure out the third to complete the 360. So in this case, I'm just going to use a triangle. We said it's 12, therefore this is 24. It's a little bit simpler, I think. All right. And then on D, part D is kind of similar to A and B together. We have this central angle that's kind of given to us, and so that's nice. Central angle and its arc are always the same, so I'm going to say this is 56 degrees. And then the y is going to be half of the central angle, which in this case we want to take half of 56. So 56 divided by 2. So what is that? 48, I think. Not 48. Oops, 28. All right, if I'm wrong there, let me know. And part E, we're looking at this one. Maybe it's not clear. I believe this arc here is 114 degrees, which means if I look at this central one, it should be the same. So x should be 114 degrees as well. And if I look closely, y, if I look at this angle and I extend it, you should notice it has the same arc, 114. But this one is an inscribed, so it's going to be half of, this is going to be 114 divided by 2, which then gives us 57 degrees. And then the last one, again, we're looking at, we have an inscribed angle given to us. You'll notice I extend the lines all the way till I reach the circle. So this 28 and this arc, this intercepted arc, have a connection. So this one's going to be double, x is going to be double, 56 degrees. And if I look at y, I notice that they have the same intercepted arc. So which means this is also going to be, this y value is going to be 56 divided by 2, which is equal to 28 degrees. So you should notice these angle measurements are exactly the same. So y and 28 are exactly the same. Technically, I could draw in any other angle. As long as it connects to the same arc, it's going to be 28 degrees. So I could literally draw in a whole bunch of these, and they're, oops, that one wasn't very good. So I could draw in as many as I can that use the same arc, and it will still be 28 degrees. All right, so that was a quick run through. Maybe rewatch that if you need guidance. The rest of this is on our review preview. Problems 66 to 73 are there for you to practice. If you need some math notes, there's some available there in this lesson as well on circle vocabulary. As usual, everything else is a good review of prior topics. The only thing I would like to do is maybe mention on problem 66. It does look even more complicated than what we've seen. It kind of mixes in a lot of lines. Do your best to not get distracted with all the lines that are going on, and take the time to look at what you have and identify. Maybe use different colors, and make sure you extend the lines so you could get a good picture of the angle and the arc that they're talking about. So remember, every arc has an angle. So arcs and angles go hand in hand. So if you have an inscribed angle, that must mean you have an arc. If you have a central angle, you must have an arc as well. So there's a relationship between them. So remember, central angle and its arc are the same. Inscribed angle is half of its arc. So again, so angle D, maybe even color in D as well, which again has that same PF. You'll notice the same intercepted arc. And I'll even throw in one more, E. So E, you'll notice, has the same B and F. Right? So take the time to maybe use a highlighter or color. Once you find one piece of information, it's going to help you find all the others. So that's my last tidbit for you. So, all right. Let me know how it goes. If you have any questions, send me some messages. Alrighty.